thank you everybody for the opportunity to speak with you today. This is a really important topic, and it's also very timely. We're going to be moving into winter season, where a lot of what we talk about will be front and center in everybody's eyes, ears, and minds. So once again, my name is Scott Kuykendall. I'm Water Resources Specialist for the McHenry County Department of Planning and Development. I help oversee our scientific research into water resources. I help set public policy. I maintain the county's environmental compliance, and then I do public education and outreach. And that's really one of the most rewarding parts of my job, is being able to communicate with the public all the things I get paid to learn. So one of the big things has been learning how chlorides impact our water resources and the tools that we have to address that. So today we're going to be talking about the connection between our use of road salt and our water resources. So we live on a blue planet where about 75% of the Earth's surface is covered with water, but only about 2.5% of all the water on the planet is fresh water. And of that fresh water, most of it's currently locked up in the ice caps. When it melts, that flows into our oceans and becomes salt water. Most of the remaining 30% is either inaccessible or unusable. So what this all amounts to is that only about 0.007%, if everybody can mute your mics, that'd be greatly appreciated. So what this amounts to is only about 0.007% of all the water on the planet is available to us to use. And we need to share that with a lot of other species and a lot of other people. So we're now approaching 8 billion people on the planet. It only took 200,000 years for the first billion people to be established on the planet, but only 200 years for the next 7 billion people. So we've got a lot of people relying on that 0.007% of available water. And unfortunately, our actions are polluting that 0.007%. And water is necessary for all living things. Whether you live in the tropics, the tundra, or the Midwest, water is necessary for all life. It is also necessary for all economic development. You're not going to get people to invest in homes or businesses if you don't have access to safe, clean, reliable, and affordable water. So water is going to be the economic driver as we move forward. And unfortunately, water is scarce in much of the world. That 0.07% is actually a large volume of water, but it's not evenly distributed across the planet. So in 2018, approximately 3.6 billion people suffered from water scarcity. That is rapidly increasing, and by 2050, it's estimated that nearly 9 billion people will suffer from water scarcity. However, we here in the Chicago region in northeastern Illinois have the ability to have safe, sustainable water, but that's only true if we protect it. So in Illinois, we get water from a variety of sources. Up in northeastern Illinois, a lot of our water obviously comes from Lake Michigan, but a lot of us also rely on groundwater for our water. As you go downstate, those groundwater resources become scarcer and scarcer. And most of the water comes from reservoirs that were created from damming rivers or streams. So this is a closer up view of the Chicago region. And once the lighter blue is all Lake Michigan, but you can see a lot of shades of brown, and those are groundwater aquifers that are tapped into. So in McHenry County, we rely 100% on groundwater for our drinking water. Kane County gets most of its water from groundwater, but there are communities like Elgin and Aurora that rely on Fox River. We have a variety of sources, but these are all susceptible to pollution. So this is a cross-sectional view of our geology and aquifers in northeastern Illinois. And the upper layer is a layer of sand and gravel, and this was deposited during the last glaciation period. As the glaciers came and retreated, they deposited a lot of sand and gravel in parts of our region. And in McHenry County, that's our number one source of groundwater, is the sand and gravel layer. And that's also an important resource for many communities throughout the region. Below that is a layer of limestone, and limestone is a hard, rigid rock, but it has cracks and fissures. So water that is able to infiltrate down through the sand and gravel can fill these cracks and fissures, and where they're perfectly aligned, they can actually provide a lot of water that can be used as an aquifer. And then below that, we have 3 layers of sandstone that are encompass a large area. The main one that's being used is in Ironton, Galesville, and because these areas are recharged from long distances away, the recharge rate is very slow. So these are not renewable aquifers, and the Ironton, Galesville is actually being drawn down to the point where it's considered a dying aquifer. So that upper layer, the sand and gravel and limestone, are going to have greater and greater significance as we move forward. So in a natural hydrologic system, when it rains or snow melts, water is able to infiltrate down through the ground and recharge the water table. But water is not sitting still. Water is constantly moving, and at periods of days, months, years, or decades, that water is moving downhill and ultimately releasing into our lakes, rivers, streams, and wetlands, where it provides a base flow of cool, clean water throughout the year. In a urbanized setting, however, where we've paved over the surface or where it's been compacted, the water is no longer able to infiltrate down into the ground. So it hits the ground surface and rushes off rapidly, carrying with it any pollutants it comes in contact with, and creating a flood stage in our lakes, rivers, streams, and wetlands, followed by drought, flood, drought of hot polluted water. So we've created a very altered hydrologic system. And what we're really trying to do now is restore natural hydrology to our built environment and reduce the amount of pollution that can be encompassing both our land surface or infiltrating down along with rainfall. So our water resources are vulnerable to a variety of threats. Overconsumption. So if we are drawing water out faster than it's naturally being recharged, and the water tables drop. We are paving over more and more of our recharge area. So the ironic thing is, where we have the highest population density and need the most water, we've reduced the amount of recharge that is actually providing that water. And then drought. McHenry County is just coming out of a major drought that lasted from about 2020 to 2022. And so during periods of drought, we're no longer getting that recharge, and we actually start using more and more water for irrigation. And so we can rapidly draw down our aquifers when we're drawing water out and it's not being recharged. And then pollution. Basically anything we put into the air, onto the land, or into the ground has the capacity to cause pollution. And we are using a lot of salt, and it is contaminating our water. So the main culprit is road salt, but we can also get chloride contamination from water softeners and fertilizers. And salt in our water is toxic to fish and wildlife. It kills vegetation, and it's highly corrosive, and we'll talk a bit more about that. So as Jeff alluded to earlier, chloride or salt is very soluble in water. So salt is made of sodium and chloride, and the chloride dissolves instantly upon contact with water. And once it is in that water, it's very difficult to remove. There are no natural processes that are going to remove it until evaporation. And so chlorides can accumulate rapidly in our water. There is a class 1 potable groundwater resource in the state of 200 milligrams per liter. The EPA has a secondary drinking water standard, so it's not a regulatory standard, but it's a recommended standard of 250 milligrams per liter. And that 250 milligrams per liter is where salt begins to taste salty, or water begins to taste salty. Just for comparison, a natural background level of chloride in our region is usually below 1 milligram per liter. And the measurements that we're reading in the area generally exceed that 1 milligram per liter. So anything above that level is from man-made sources. And 1 teaspoon of salt permanently contaminates a 5-gallon bucket of water forever. And we use a lot of teaspoons of salt in our environment. So a container of salt that many of us have on our countertop will contaminate 4 years worth of drinking water for a person and make 30 gallons of water unlivable for fish forever. A more realistic size is a single salt truck which will contaminate about 65,000 years worth of drinking water for a person, or make 500,000 gallons of water unlivable for fish. And we use a lot of salt trucks. Salt can damage plants and soil. So as you drive around, you'll see brown trees, and that's from salt damage. You'll also see areas that can't grow anything any longer. And so our soil or our salts can damage both the plants directly and permanently damage our soils. And this creates an opportunity for salt tolerant species to outcompete our native species. So as the salt content and chloride content increases in our runoff, you'll see wetland areas go from very diverse, high quality habitats to nothing but cattails. And more recently, Phragmites. I think most people on the call are very familiar with Phragmites, but it is a true monster, and it gets its foothold in our wetland areas, our right-of-ways, our drainage ditches, and then spreads outward everywhere. And it's very difficult to eradicate once it gets established. And low concentrations can kill fish and wildlife at the base of the food chain. So our phytoplankton, zooplankton, and small macroinvertebrates are very susceptible to low concentrations of salt. And as they die off, that has a ripple effect throughout the food chain. So even small concentrations of chlorides in our aquatic environment can have a extremely damaging impact on the aquatic wildlife. And when we're talking about concentrations of chloride in our waterways, it can either be a short term. So in the spring, when we have runoff from our snowmelt, that'll carry high concentrations of salt into our waterways, and it'll have a short-term impact as it moves through our systems. But it can also accumulate in our lakes and in our groundwater, and that will create an opportunity for chronic exposure over the long term. And the EPA has created a wildlife aquatic life criteria table where they have a maximum recommended exposure level of 860 milligrams per liter for acute concentrations, and no greater than 230 milligrams per liter for chronic concentrations. And like I said, the exposure spikes seasonally when runoff carries chlorides to water bodies. But as our groundwater have higher and higher concentrations, though that is providing a base flow of higher concentrations to our lakes, rivers, streams, and wetlands. So what was once more of a acute problem will become a chronic problem as the chloride concentrations in our groundwater increase. So sodium chloride has a higher water density, which settles into the deepest part of the lakes. Lakes turn over naturally, seasonally, so it'll bring nutrients from the bottom up to the surface and bring oxygen from the surface down to the bottom, and support aquatic life throughout the lake stratification. But as the concentrations of chloride increase, that turnover is disrupted. And so the oxygen is never able to reach the lower levels of the lake, and nutrients never reach the surface. And this is extremely problematic because the fish need the deeper areas to survive winters. So as the chloride concentration in our lakes increase, it can completely disrupt that cycle and just kill wildlife. And chloride is not only damaging to our natural environment, it damages our built environment as well. So road salt can damage asphalt and concrete. You'll see pitting rapidly increasing as the concentration of chlorides onto the pavement increases. And chlorides are also the main source of corrosion to our steel reinforcement in concrete, metallic pipes and structures, so our infrastructure along our roadways, and then metal and cars. And there are a lot of roadways in the Chicago area. So Chicago has 28,000 linear miles. I believe McHenry County has about 25,000 linear miles. And so most of our counties are going to have similar amount of linear miles. And most of those linear miles are going to have 2 lanes, 3 lanes, 4 lanes or more. So that's a lot of surface area being treated with salt. And it's not just our roadways that we salt. Basically, any paved surface, whether it's parking lot, driveways, or sidewalks, is going to be treated with salt. So we're putting an awful lot of salt into our environment. But this has not always been the case. Our use of road salt really started at low levels in the 1960s and continued to escalate exponentially since then. When I was in high school, I started high school in 1980. And at that time, only the main roads in our town would be clear. All the other side roads would have ice pack on them. And my main mode of transportation in the wintertime in high school was skitching. I don't know if we have anybody else who were budding juvenile delinquents in high school, but that was my main mode of transportation. And what skitching is you run up behind a car and grab onto the bumper at a stop sign and then get dragged behind the car, sliding on the ice pack until you get to your destination. And so that literally was my main mode of transportation in high school. You would not be able to do that today. Today, everybody expects the roads to be like a sunny summer day in the middle of a winter snowstorm. And our expectations may be a bit unrealistic. This is a animated slide that was prepared by the Illinois State Water Survey based on a study they did in Kane County. So it's showing the increased concentrations of chloride pollution in our aquifers. The left panel is showing our sand and gravel aquifers, and the right panel is showing the shallow bedrock or the limestone aquifers below the sand and gravel. And it uses color coding to show the increase in concentrations. Once again, our secondary drinking water standard is 250 milligrams per liter. So that is shown in orange. And this will show the increased concentration of chlorides in our groundwater from 1965 to 2015. So we start using salt in the 1960s, and almost immediately we start seeing chloride concentrations increasing in our groundwater. And what is becoming apparent pretty quickly is that there's a direct correlation between the chloride pollution and our use of road salt on the roadways, because the concentrations are following the population densities and the roadways. So by the 1990s, we're starting to see a larger number of hotspots develop. So areas with concentrations at or above drinking water standards. By the 2000s, those hotspots become pretty pronounced and prevalent, both in the sand and gravel aquifers and in the shallow bedrock aquifers. And then as time goes on, those concentrations increase. So this is a pretty dramatic demonstration of the increased concentrations of chloride in our groundwater and the direct correlation between our use of road salt and the chloride pollution. And this is not unique to Kane County. This is what we're seeing around the country and even around the world. And areas that have been using salt longer are having greater and greater problems. Some parts of the country out east, people are actually having to replace their hot water heater every couple of years because of the amount of corrosion that is occurring from their tap water. So unfortunately, there is currently no alternative to salt for snow and ice management. There really is, it just is no magic alternative. So our best option is to use salt wisely. And we call that sensible salting. A lot of other places will call it salt smart, smart salt, salt wise, etc. But we're all talking basically the same thing. I chaired the organization called the Northwest Water Planning Alliance. They have a sensible salting committee. And our definition is the use of best management practices for snow and ice management that maintains safety for pedestrians, drivers, vehicles, and property, while eliminating the unnecessary use of salt to minimize impacts to water and the environment. So that's kind of a mouthful, but I highlighted two main points there. And one is that we are talking about maintaining safety. This is not about taking shortcuts and reducing safety. We're absolutely talking about maintaining safety, but what we're doing is we're eliminating the unnecessary application of salt. Right now, our current practices are putting down so much more salt than is actually needed. All that salt that is beyond what is actually needed is just waste. It's providing absolutely no benefit to our communities, but it's coming at great environmental and economic cost. So we want to maintain safety, but eliminate the unnecessary application of salt. So there are different scales that we can talk about sensible salting. So at a residential scale, the main thing is that you need to physically remove as much snow as possible, whether it's using a shovel, a snowblower, or a plow. But it's physically removing the snow, and you want to do that before compacting the snow by walking on it or driving on it, because that'll press the snow against the surface and form ice, which will require greater and greater amounts of salt to eliminate. So you want to remove as much snow as possible before any of that compaction can occur. And we do not want to use road salt or other deicers to just burn off the snow. You need to physically remove the snow and only use the snow or chemicals on ice. It's also important to understand that there is no such thing as an environmentally friendly deicer. As you select your materials, you're going to see the term environmentally friendly on packaging all over the place. There is no such thing as an environmentally friendly deicer. All forms of deicers have some impact to the environment. And once again, we do not want to use road salt or other deicers to burn off the snow. We only want to use that on ice to break up the ice. And you can also use sand or kitty litter to provide traction at the residential scale. So what I typically do is I will focus any salt that I have to put down on areas where people are like making a turn, where pedestrians are making a turn and pivoting. And what I usually do is I'll put a handful of salt a handful of sand at that location, so that when they are pivoting to make a turn on the pavement, they are not, that they actually have traction. So I'm targeting my application of both salt and sand. And different deicers work at different temperatures. So our common rock salt is sodium chloride, but that's only effective down to 15 degrees. So if you're trying to put down salt at 0 degrees, it's not going to do anything. And what people end up doing is they put more and more down, trying to burn things off, but it's too cold to work. So calcium chloride is effective down to -25 degrees. It's fast acting, and it's the most effective deicer, but it's commonly regarded as the most corrosive option. And a lot of municipalities really try and limit the amount of calcium chloride that they use because of the damage it does to their infrastructure. Magnesium chloride is effective down to 0 degrees, and it's considered by some to be safer for pets and vegetation, but it may be somewhat less effective than calcium chloride. So once again, you need to look at the temperature that you're going to be applying it at and make a judgment call in that regard. Calcium magnesium acetate, or CMA, is considered to be the least environmentally damaging deicer. It's not a chloride-based product, but it's only effective down to 20 degrees. And it also has nutrients in it. So when the nutrients run off into our waterways, it can cause oxygen depletion in our water bodies. So once again, there is no material that we can put down that doesn't have environmental impacts. When we do apply our salt, we want to have a reasonable dispersal pattern. So the pattern on the left is more what we should be shooting for, not the pattern on the right where you're going crunch, crunch, crunch across the driveway. Basically, each kernel of salt will melt a 12-inch diameter radius. And so you can have a dispersal pattern that reflects that when you're putting your material down. Any excess de-icer provides no benefit, but once again has environmental and economic costs. And then I usually use what I've got is a hand spreader that has different settings. So depending on the type of material that I'm putting down, I can adjust it so that I can get the proper dispersal pattern. And the other thing that does is it allows me to target where I'm actually applying it. So like I said, I try and only put material down where I've got an area where there's an incline on my driveway. So people walking from the driveway to the house would have to go up an incline. So I try and target my application there. And then people have to make a 90-degree turn on my walkway. And so I will make sure that I'm targeting where I apply the material using the hand spreader and make sure that it's adjusted so that I'm putting a proper dispersal pattern down. So roads and parking lots have different tools available to them. And when we're talking about sensible salting tools, we do have a lot of tools in the toolbox when it comes to roads and parking lots. The main thing is proper salt storage. There is no excuse for open piles like you see in the bottom left. That pile was behind a strip mall in Crystal Lake, and it was actually sitting on top of a storm sewer. And that storm sewer is completely corroded, as is the metal inside the storm sewer. So they have completely damaged infrastructure from improper placement of the pile. And the other thing that happens, it turns crusty, so they can't even use it. So this pile was probably sitting there for years because it was all encrusted. At the very least, we want to have any material that's on the pavement located in an area that's high so that you don't have runoff flowing to it. And you want to keep it covered at all times. What you'll sometimes see is concrete blocks on three sides holding the pile in place and a tarp weighted down by tires. That's not ideal, but it's better. What I'm actually seeing a lot more of now, and this is actually what they did in place of the pile on the bottom left, is they use storage containers, so the shipping containers. So the material is now completely enclosed and off the ground. But there are so many options available now. So if there are going to be permanent piles in a location, whether it's a DOT or behind a strip mall, there should be some type of permanent cover provided. We just have so many options available to us now. There's no excuse for open piles. Calibrating equipment. Equipment does not come calibrated and it doesn't stay calibrated. So you need to calibrate your equipment annually. If your equipment's not calibrated, you have no way of knowing how much material you are putting down. So you need to calibrate your equipment and then put down the correct application rate. And as we talked about before, we want to have an application rate more like the left-hand side of the screen, not the right side. If you have improperly calibrated equipment, you're putting down piles similar to what you see in the middle picture on the right side. And those piles are going to last there far beyond any storm event. And that'll just leach into our groundwater and our waterways, providing absolutely no benefit to society, but coming at great environmental and economic cost. And I think we've all experienced where we've walked across parking lots from our car to the store where literally was crunch, crunch, crunch. That's not acceptable anymore. Salt actually needs to be wet in order to work. For putting it down dry, what we're actually relying on is the friction of the tires going across the salt and creating friction to trigger melting and the action of the salt. But if you're putting it down wet by applying a brine before it hits the ground, you're putting it down in an active state where it is starting to work immediately. So it improves the effectiveness. The other thing it does is if you're pre-wetting your salt, instead of it hitting the ground dry and bouncing off into the right of way where it's providing no benefit, becoming at great environmental and economic cost, if you're putting it down pre-wetted, it's more likely to hit the ground and stick where it's actually going to work. And that means that you're going to have put less and less down in reapplication. And then you can add different types of materials. So when we talk about beet juice, it's usually as an additive to our salt or brine that improves its effectiveness. And so this is where we talk about anti-icing. So I think most people are pretty familiar with the striping that you'll see on the roadways before a storm, but this is putting down liquid brine before a storm. And this is where the beet juice has been added. And it can be other types of material, but beet juice is the common ones. And so the beet juice acts as a carbohydrate that helps the salt stick to the surface so that it'll stay there until and during a storm. And by having a liquid brine on the roadway, that prevents ice from forming. And since ice isn't forming, that makes it easier to push the snow off and prevents the formation of ice, which would require reapplication of salt over and over again. So you're actually making the road surface safer and requiring less and less salt be reapplied. And so we really want to see anti-icing applied universally on our roadways and parking lots. And some communities and counties are actually moving to liquid only. So here in McHenry County, our Division of Transportation now has 4 routes that are only using liquids. They started out conservatively and really monitored performance and all kinds of metrics. And each of their routes yields about a 38% reduction in road salt usage over conventional treatment. And so that 38% reduction translates both to less chlorides being put down on the road and cost savings. And the cost savings are pretty significant. We now have a new tank farm that has secondary containment. So if one of the tanks were to break, the liquid would be contained. But we're able to create different mixes using our liquids depending on the road temperature and conditions. So it's really proven to be economically and environmentally and greater performance, much better than conventional treatment. And this is not applicable across the board, but this is a great program called Living Snow Fences. And one of the common things that's done is you work with farmers and compensate them to leave about 18 rows of corn up at the end of the growing season. You want the rows about 100 feet from the roadway. And what this does is this captures snow and prevents drifting onto the roadways. And drifting is actually one of the biggest problems we have on roadways in wintertime because it creates major hazards. And we have to remobilize over and over again to plow and apply salt. And by having our living snow fences up, that prevents the drifting. It significantly improves safety on the roads, reduces the mobilization that our crews need to do, and reduces the amount of salt that needs to be reapplied. So this is a great program, and you can have living fences with leaving row crops up, or you can create permanent living snow fences using a combination of shrubs and native vegetation. And so this is something we really would like to see more and more along our roadways. Up in Wisconsin, I know that they've invested a lot of money on the highways there. And you'll see strips of shrubs that have been planted as you go north on I-90 up into Wisconsin. So, and sensible salting training. So most of our counties have been providing annual workshops for over a decade, and we've helped train over thousands of people from municipalities and organizations. And we have a variety of workshops that are coming up. There are virtual de-icing workshops that are being provided virtually here in northeastern Illinois. So you can see the flyer on the right, and I'll get a copy of this to Jeff for him to distribute to everybody. But we have programs coming up for public roads online, or parking lots and sidewalks. And then here in McHenry County, we do an in-person program. We're pretty proud of the workshops that we put on. These are half-day events in person. It involves both classroom, and then we also then move out to the garage and show you exactly how to calibrate the different types of equipment that we use. So we have a hands-on program in addition to the classroom. And I'll provide both these flyers to Jeff, and feel free to contact me as well. So the previous one is just simply, you can go to saltsmart.org. And then for the McHenry County one, you can get more information at our website at McHenryH2O.com. So once again, that's just McHenryH2O.com, and that gets you to our main water resources webpage where I have all the information. So I mentioned before that I chair a Northwest Water Planning Alliance Sensible Salting Committee, and our goal is to protect water quality by reducing the unnecessary release of chlorides to water from snow and ice management. And what we found is that most counties and many municipalities and other governmental entities are working on salt reduction, and we have some way of influencing how that's done, but the private sector has no oversight and actually incentivizes the excessive use of salt. So the greatest opportunity for us to influence salt reduction was actually in the private sector. So we developed a strategy to try and reduce the amount of chlorides being placed on private properties. And the first step was to develop a regional sensible salting manual so we could all be working off the same page, establish a professional regional training and certification program. Then we would work with municipalities to create policies that require certified operators. And then ultimately, based on the sensible salting manual and certification program, pass state legislation that provides limited liability protection for property owners that hire certified operators who are using proper sensible salting practices. And one of the reasons you see so much salt abuse on private properties is worry about slip and falls. And so by having limited liability protection, you would be driving the use of sensible salting practices and using market forces to facilitate that change. So these were long-term plans, and fortunately, the Conservation Foundation really took the ball and has run with it. So they have a program called the Salt Smart Certified Program for parking lots and sidewalks. And this will be coming out in 2023 through their Salt Smart Collaborative. And it'll be a program called Salt Smart Certified. And this is specific for parking lots and sidewalks. Unlike trainings that have been provided in the past, these are going to be tailored to private contractors in Illinois, but it is also very practical for other organizations and agencies like school districts and others that have focus on parking lots and sidewalks. So the Conservation Foundation received a 319 grant for about $300,000 to develop an Illinois-based parking lots and sidewalks training program and manual. We had a steering committee that guided the development of these things. The manual is now complete, and we're in the final phases of developing the training program, and it's slated for release in 2023. So they are looking for more input from private contractors. We really want to vet this and make sure that this is a program that's going to be effective for the target audience, which is private contractors. If anybody wants more information, please go to saltsmart.org, and you can get all the information and contacts for Hannah and Jennifer at the Conservation Foundation. So parting thoughts, you can use sensible salting practices at your home or business, hire snow removal contractors who are knowledgeable or certified with anti-icing and sensible salting practices at your home and business. Work with your businesses, schools, or building managers or other responsible parties to train staff and implement sensible salting practices, and then work with elected officials or local public works departments to help them expand their anti-icing and sensible salting practices. So one of the obstacles we had even here at our county administration building was our safety officer. And we really had to explain the importance of all this and how it all works for us to be able to implement these types of programs with our contractor here at our county administration building. But we've now been doing this for a while, and it has improved the performance. So we are able to get to bare pavement much quicker than we were before, with less vehicles causing hazards on the parking lot. So we've really improved performance, improved safety, and reduced the amount of pollution that we're providing on or creating on our own properties. So we're walking the talk and doing what we're supposed to. And so if we're all working at our own entities, we can be affecting change, in our own worlds. So these are all things that we should be working on together. Parting thoughts: the Chicago region is fortunate to have clean, reliable water resources, but that's only true if we protect them. Clean water is necessary for all life. Clean water is also necessary for all economic development. And our use of road salts and deicers are polluting our water. So we all need to implement sensible salting practices to protect that water. And that's all I've got. And I'd be happy to answer any questions.